Hello guys, how is it going? Now if you're watching this video, then I'm sure you already know what force is. So let's take a quick recap. So force is basically a push or a pull action which is born out of an interaction. Now the interaction can be due to a contact between two objects or it can be without any contact as well. Now a force is capable of making a resting body move. It is also capable of making a moving body come to rest. It is also capable of changing the speed and direction of a moving object. And finally, a force is capable of shape deformation or changing the shape of any object. Now, in physics, we have several physical quantities like mass, length, temperature, speed, etc. And you should know that force is also a physical quantity. Now, all physical quantities are measurable. For example, the mass of your body could be 50 kgs or the height of your body could be 160 centimeters. So here you can see we are able to measure the mass and the length of your body. Similarly, your school can be 5 kilometers away from your house, which is nothing but the measurement of distance or the measurement of length. And similarly, you may ride your bicycle to your school at an average speed of 20 kilometers per hour. Here you can see you are able to measure the speed. So all these numbers or all these values that we are assigning to these quantities are also called their magnitude. The English word magnitude means the size or the extent of something. So the magnitude of a physical quantity tells us how big or how small that physical quantity is. For example, a 50 kg object weighs more than a 20 kg object because the number 50 is more than the number 20. Similarly, a 2-meter long wire is longer than a 1-meter long wire because the number 2 is more than the number 1. I hope you already know about this. So just like the other physical quantities, force also has a magnitude. But before I give you an example, let me tell you that the SI unit of force is in fact newtons, named after the great scientist Isaac Newton, who is often considered as the father of classical mechanics. So let's move on to the example now. So let's say me and my friend apply different amount of forces onto this punching bag. So let's say I apply a force of 50 newtons versus my friend who applies a force of 500 newtons. Now, who do you think applied more force over here? Clearly it was my friend, right? Because his punch sent the punching bag flying, while my punch couldn't do much. But wait, let's hold on for one moment, because there's a catch here. And the catch is that we cannot describe force completely using only its magnitude. Does that make any sense? Can you think of any example where force needs something else apart from magnitude to completely describe itself? Well, let me give you an example and show you how it works. So let's say you and your hypothetical twin brother, who's as strong as you are, have a task at hand. The task is to push this heavy box towards the left wall across the room. Fair enough. Now, for the purpose of explanation, assume that both of you can apply a maximum force of 100 newtons. So, game on. Take a moment and think, how should the two of you push this block? So, did you get it? I'm sure you did, because this is an easy one. To move the box towards the left side, both of you should collaborate together and push it from the right. Why? Because when you apply forces in the same direction, your forces add up, and a maximum of 200 Newton force can act on the block. More force means more chances that the block would move. However, what if your twin brother is not so smart and begins to push the block from the left side instead? Well, in that case, both of you would be applying equal forces but in the opposite direction. Or in other words, the two of you would be cancelling out each other's forces or each other's efforts. And not to mention, the block would certainly not go anywhere. So, what is our main takeaway from this example? Well, the main takeaway is that merely stating the magnitude of a force is not enough. We need to supplement that information with an extra information of the direction. So, two forces acting in the same direction add up, while two forces acting in opposite directions cancel out. So, the direction of a force is a very important piece of information. Interesting concept, right? But you see, not every physical quantity needs a direction to completely define it. For example, physical quantities like mass and temperature can be completely defined using only their magnitude. So sentences like, my book weighs 500 grams or my body's temperature is 37 degrees Celsius is logical and complete in itself. However, if I say something like, my book weighs 500 grams in north direction while 400 grams in south direction, then it is completely absurd and illogical because we know that mass doesn't change with the direction. Now, at the same time, force is not the only physical quantity that needs both magnitude and direction to define it. There are other physical quantities like velocity and displacement that need both magnitude and direction to define them. Now, to give you some idea about what these terms mean, I can say that velocity is nothing but speed with a direction, and displacement is nothing but distance traveled with a direction. In case you did not understand this, don't worry, because you will learn about these terms in detail in your higher standards. But I can say that sentences like, my school is 20 kilometers north from my house is completely sensible. And so is a sentence like, today the wind is blowing at 30 kilometers per hour towards the east. Because here we are describing displacement and velocity, which have both magnitude and direction. So guys, that's it for today. I hope you had a good time throughout this video. In the next video, we'll take up the concept of pressure, which I think you know something about, but don't fully understand. So I'll see you soon again in the next video. And for now, let me summarize what all you learned today. Quantities like mass, length, temperature, speed, force, etc. are considered as physical quantities. The magnitude of a physical quantity tells us how big or how small that physical quantity is. For example, a 50 kg block has more mass in it compared to a 20 kg block. That's why a 50 kg block weighs more. Physical quantities like mass and temperature can be completely defined using only their magnitude. However, physical quantity like force need both magnitude and direction to completely define them. Forces acting in the same direction add up, while forces acting in opposite directions cancel each other out.